Have a paper and pencil ready so you can take notes, and let's get started. We should first talk about what gases are. Gases are one of the three phases of matter, the others being solid and liquid. You could probably think up some examples of gases. The thing we breathe in, oxygen. The thing we breathe out, carbon dioxide. The thing that makes up 70% of the atmosphere, nitrogen. And the thing we have detectors for, so it doesn't kill you, carbon monoxide. These are all gases, and they have some common characteristics. 1. They can easily be compressed. Basically, you can force the gas molecules to come closer together. This is different from most solids and liquids. For example, if I have 1 liter of water in a container, and I try to compress the water so that way it would occupy less space, my container would probably break before the water compresses. Number 2, they're less tangible. I could carry liquids and solids in my hands, but gases are a little harder to hold, even if they exist all around us. And lastly, gas molecules are a lot farther apart from each other than liquids or solids. When molecules are the closest together, they tend to be solid. As you heat them up and the molecules start to jiggle more freely, they become liquid. And finally, when they're completely detached from each other and move freely in all directions, they are gas molecules. Just like solids have characteristics like color, density, and texture, gases also have physical properties. The ones that we'll be focusing on the most is volume, temperature, pressure, and quantity. We'll be going through these physical properties, defining them, how they look like in the molecular level, and giving common units. First up is volume. This is how much space something takes up. It's not about how heavy it is, it's just about how much area it occupies. For example, if you blow up a balloon, you're increasing its volume, but not its mass. And when you deflate a balloon, its volume decreases while its mass stays the same. For volume, you could think of it as the amount of space between each molecule. As the gap increases, the volume increases, even if the number of molecules and the mass of the molecules stays the same. Common units for volume are milliliters and liters. Secondly is temperature. You may know this as how hot or cool something is, but scientifically speaking, it's the average speed of molecules. As molecules move faster, the temperature increases. When you heat something up, you're giving the molecules more energy. The molecules use this energy to increase their speed, causing the temperature to increase. As you cool something down, the molecules start to slow. A common unit for temperature in the US is Fahrenheit. However, in science, Celsius and Kelvin are more common. You probably never heard of Kelvin before. It's pretty much the degrees it is in Celsius plus 273.15. So room temperature of 25 degrees Celsius is 298.15 Kelvin. But the really cool thing about this unit is that zero temperature is the coldest temperature there could possibly be in the entire universe. 0 Kelvin is called absolute zero. This is a temperature in which no molecules are moving or vibrating. Things are 100% still. We know that the universe is vast and pretty much empty. But how cold is it exactly? Well, the average temperature of the universe is 2.73 Kelvin above absolute zero, which is pretty darn cold. The coldest temperature to ever exist in the universe, however, most likely happened somewhere near Boston, in Cambridge, Massachusetts. MIT, working with NASA, cooled sodium gas to 1/2 billionth degree above absolute zero in 2003. That's insane. Okay, moving on to our third property is pressure. We all know that high pressure can be dangerous. I mean, pressure cookers have injured and even killed people on multiple instances. But what exactly is pressure? Well, pressure is the force exerted by a substance over a given area. So what's happening when you increase the pressure? Number one, when you increase pressure, there are more collisions over an area. To represent this, here is a video of my hands. My hands are representing the molecules, and the surface of the table is representing a specific area. I can demonstrate the number of collisions increasing by using both hands to hit the table or by hitting the table more frequently. Pressure can also increase when gas molecules hit the wall harder. I can represent this by making my hands move faster before they hit the table. When they do that, they hit the table with more pressure. Common units for pressure include standard atmosphere and pascals. Standard atmospheres are what's used to measure pressure of the atmosphere. For example, at sea level, there is 1 standard atmosphere. Pascals are used to measure everything else. For example, a can of Aerospray is usually around 345,000 pascals. Lastly, the fourth property is quantity. This is simply the amount of gas molecules there are. A common unit for the quantity of gases is a mole of gas. We know that molecules are pretty darn small. So in order to describe an amount of gas molecules that we can see and understand, we need to have a large amount of molecules. A mole of molecules is 6.022 times 10 to the 23rd molecules, which is a ridiculously large number, but that's how much we need in order to get to quantities that matter for us. Okay, so here's the summary of today's lesson. We talked about what gases are and characteristics that gases have, namely volume, temperature, pressure, and quantity. These are the definitions of each, and these are common units for each of them. In the next video, we will be looking at problems involving gases along with applications.